Hey everyone! Are you gearing up for your GCSE computer science exam? Are you particularly struggling with the paper 2 of the AQA specification for GCSE computer science? Well, if you are, in the right place you are. Yep, you are, as in you're in the right place. My YouTube channel called Learn Computing with Daniel Bullen, with me, Daniel Bullen. So before I go into what we're going to do, please remember to click that like and subscribe button, and click share, click the notifications bell, and share this video far and wide to help your pals, your fellow coders, your fellow computer tech geniuses whiz through this exam just like you're going to be because you're watching this video. So, I'm going to be doing a deep dive into paper 2 where we will find out all the key topics, tips, strategies you need to ace that examination. So whether you're looking to boost that grade or just need a simple refresher, stick around because we're going to unravel the secrets to mastering paper 2. And when I mean secrets, I don't mean analogies on silly recipes or some people with OnlyFans accounts, but I'm not going to get into that. Let's get started, we shall. Yep, not going to go through the la-di-da as invigilators do that just before the exam. So I'm not going to go through the la-di-da. Let's get right into it, into the proper thing. So, first question, convert the binary number 11010100. Okay, what do we do? What are we doing here then? Well, it's a 1-mark question. So, what I would do is 128, 64, 32, 16, 8, 4, 2, 1. Bosh. Right. Going to do 1. Yep, so we're doing 128 plus 64 plus 16 plus 4. So, what are we going to do here? 128 plus 64. 192. Plus 16. That will be 208. Plus 4. 212. That's literally it. It's literally primary school maths. Nothing magical. It's not maths I'll take you through walls or allow you to jump through the ceiling, jump over, doing some backflips. It's just simple primary school maths. So if you get 212, that's correct. Next one. Now we need to convert this binary number into hexadecimal. So let's break it up, shall we? So we're going to 8421 because we are breaking the bits, the bytes into 2 nibbles. Okay, so what have we got here? 8 plus 2 is A, plus 1 is B. And we got 8 plus 1, that's 9, so it's going to be B9. Bosh, done. Okay? The reason why I said B, because if you think about it with hex, 8 and 2 is 10. 10 in hex is A. Plus 1, 11. 11 is B. Bosh, done. Right, something like that. That's 2 marks. Bosh, done. Next one. Now we need to state the largest decimal number that can be represented using 6 bits. Well, the largest that's going to be represented is going to be 63. Reason being, because 64, that goes over, and that's a 7th bit. So it's going to be 63. Done. Literally that simple. Don't need to do any calculations there. But we will here, though. Binary addition. Woo-hoo-hoo. So, we've got a big behemoth here. So this is where we need to remember the rules. So you go 0 plus 0 plus 1. That's going to be a 1. 1 and 0. That's a 0. 1, 0, 0. That's going to be a 0 also. Okay. 0, 0, 0. That is going to be... Okay, or it'll be 1 plus 0. 0. That's a 0. 0, 0, 0. That is going to be a 1, which is a strange one. Then we got 1 and 1. 0. That's a 0. 1 and 0 and 1. 0, 0, 0. Okay, so that is literally that in binary addition. You can check it by converting these into denary. So if we were to, as it's 8 bits, 32 plus 16, 48. 48 plus 6, that's going to be 54. So 54. So 54 add 148, which should really, so now we know we got that wrong, because I should not have put the zeros here. So that should be a 1, that should be a 1, and that should be a 1. So that will look a lot more accurate. So that's going to be well over 200. Okay? Alright, next one. Shifting. So with shifting, we need to apply a binary shift 3 places to the right when we've got the bit pattern 0, 1, 1, 0, 1, 0, 1, 0, 0, 0. So we are going 3 places to the left. So it's basically going to be 0, 0, 0, 1, 0, 1, 0, 1. Because we are shifting these babies leftwards. So all of this is going 3 places, or rightwards actually. So all of that, so because these need to be shifted 3 places to the right, these baby zeros need to go over on the other side. Okay? And that is our answer. Let's get to the next one. The arithmetic effect of applying a shift of 2 to a binary number is multiply that number by 4. So let's state the arithmetic. So now we need to state the arithmetic effect of applying a left binary shift of 4 to a binary number. So that would be the binary number is multiplied by 16. If it's by 4, it's going to be 16. If it's 1, it's going to be 2. 2 is going to be 4. 3 is going to be 8. 4 is going to be 16. Okay, let's try the next one. We need to state the arithmetic effect of applying a left binary shift of 3 followed by a right binary shift of 5 to a binary number. So we could say here, so it would be to divide by 4. We could have divide by 4, which would be 1, or we could have multiplies by 8, then divides by 32. So we're timesing by 8 and then divided by 32. Okay, that's that bit done. Question 3. That is where we're getting into logic land. So, we got a series of truths. So we need to complete the truth table for the XOR logic gate. So 0 and 0, that's a 0. 0 and 1, that's a 1. 1 and 0, that's a 1. Because if there's any of the numbers that are different, it's going to be a 1. If two inputs are the same, output's going to be a 0 in an XOR gate. Okay? Right, let's move on. The game has 3 sensors. Got a red light, and the game switches if all of the conditions are true. Sensor D is off, sensor L is on, sensor W is on. So we need to complete the logic circuit for this game. So we have to use the correct symbols for the logic gate. So what they would look for in this example is going to be something like this. So what we've got in here, we've got, for D, we're going to have a NOT gate. For L and W, it's going to be an AND gate. And then they're going to come together to form another AND gate, hence R being the output. So that would get you 3 marks. So 1 mark for each correct gate. Okay? Right. Boolean expressions. So we've got another circuit. In the game, we'll output true if the 2 sensors are activated, or if all 2 sensors are activated, or if all 3 are activated. So we've got it. So we've got the following Boolean expression. The pluses being the ORs, the dots being the ANDs. So we need to shade, so the expression has an error though. So we need to shade 1 lozenge, that shows the expression with the error corrected. Process elimination. It's not going to be A, it's not going to be C. And it's not going to be B, and it's not going to be D. So it's actually going to be a C. Because we are meant to have the OR operator here rather than the AND. So if you shade in C, you will be correct. Okay. Green light, G, in the game switches on if all of the following conditions are true. Sensor D is off, sensor L is off, sensor W is on. So we're going to write a Boolean expression for that logic circuit. So the way they will want you to do it is, I'm not going to try and do Boolean expressions on a computer. So I'm going to show you the mark scheme very briefly, very quickly. So it would be not D and not L and W is what you could have there. And that will literally be it. So it'd be 1, or you can have W and not D or not L, or you can have not D and W and not L and W. So it would need to be all of them. So it can be any of those, and these are supposed to mean they're ORs. But the way they design the mark scheme is quite difficult on that one. So I have to come back and check on that one. Okay. So Yep, so if you see the 2 forward slashes when you're going through mark schemes, it means alternative response. So any of the 3 responses I've just showed you just now, which is not D and not L and W, that will get you 3 full marks. Okay, on with the theory. Describe what is meant by the term system software and application software. System software manages and controls computer hardware. Application software is for end user tasks. 2 easy marks right there. Next one, state 4 functions of an operating system. So there's loads of them. So you'd have process management, memory management, application management, and security management. They would be the 4 in which I would mention. You could have input-output device management, you could have file management, or you could have network management. So there's a lot of options for those that will get you 4 marks. But it's copy and paste the mark scheme. Okay, on to number 5. This is an indicative one, so this is a biggie. Autonomous vehicles controlled by a computer system, senses the environment, and requires no input from a human driver. So we need to discuss the legal and ethical impacts that need to be considered when replacing manual, human-driven vehicles with autonomous vehicles. So you get 3 marks. So we need a structured discussion of both legal and ethical impacts of the increased use of autonomous vehicles. So you could almost do 3 marks for ethical impact and 3 for legal impacts. So something like this. So as an example, so you could have one of the impacts is trust, because the driver trusting the program, trusting the algorithms in the car to make the correct decisions, like slowing down when pedestrians are on the road. And then you could say, in relation to decision making, the car must make human-like decisions when confronted with unusual circumstances like a trolley problem. And another concern is going to be safer driving, as autonomous vehicles could be safe for drivers and human drivers, like keeping at a safe distance from the car, in the front and at the back at all times. And then legal impacts would be things like, well, liability is a grey area. Because who's going to be at fault, the manufacturer or the driver? And then there's also insurance, which will change as drivers are no longer responsible for the control of the car. And then we need to be concerned about data protection, because they have to keep the driving data secure in accordance with GDPR and the Data Protection Act. And they'll have to keep up with law updates in general, because driving laws will have to be amended to account for new types of vehicles that are going to come on the road. So those are some of the ethical impacts and legal impacts you could consider when writing a question like that. Okay. On with the next one. Programming languages can be classified as low or high level. We need to shade 2 lozenges to show the statements that are true about code written using a low level language instead of a high one. Well, process of elimination. Code closely resembles English. No, it doesn't. Code is easier to write. No, it's not. Quicker to write. No, it's not. Code never needs to be translated before being executed. Not the case. So it's going to be C, where code does not translate using a compiler. And then it's going to be E, which means the code can directly manipulate computer registers. If you shade C and E, you will get it correct. Anything else you'll just need to revise programming languages. Ooh, now we're on to something here. Okay. Assemblers and interpreters are two types of translators. State the purpose of an assembler. So an assembler will convert assembly language into machine code. That's what an assembler does. For number 2, we need to explain how an interpreter works. So if I was doing this, I would be saying something like, an interpreter works whereby they don't produce machine code, so the program has to be translated each time it is executed. So interpreters call machine code subroutines within their own code to carry out comments, to carry out commands, and translates them line by line, which then executes. And then if, however, a runtime error is found, the interpreter stops. That would be the indicative content I would say there. Because we've got a coherent and accurate explanation of how an interpreter works, and we've got references to in relation to the principles of operation. On to the next one, number 8. Okay. State 2 reasons why computers have more RAM than cache memory. RAM is cheaper, and the capacity of cache memory is typically not enough to store both data and programs. Number 9. Data is increasingly stored in the cloud. 2 advantages out of many. Cloud storage is automatically backed up by the host. Cloud storage enables users to access their data from different places. You could also have increased the amount of potential storage available. You could have reduced the cost of computing devices for the users because they don't need built-in secondary storage. But if it was me, I would say cloud storage is automatically backed up by the host, and it allows collaboration. Like I use that when collaborating with some of my students on their work or on their NEA. We'll collaborate. Okay. Number 9, part 2. Many new computers use solid-state storage rather than magnetic storage. Explain why solid-state storage is not fitted to every new computer. Reason being is because solid-state storage, they're expensive and they have lower capacity. That's 2 marks right there. Okay, number 10. So how many bits are there in kilobytes? So how many bits are there in kilobytes? So we've got to show our working here. So it would actually be 16,000, but they want the working. So this is where we need to be doing. So it could be like 6, you could do 16, you got 2 kilobytes. So 1 kilobyte is going to be 8. Okay, so we've got 16 times 1,000. That's going to give us 16,000. If you think about it, 8 bits in a byte, 1024 bytes per kilobyte. And there, so 16. So if it was 1 kilobyte, you could have 8 bits in 2 kilobytes. So in one, if it said 1 kilobyte, it would be 8,000. But because it's 2 kilobytes, 8 bits times 2, it's 16 bits. Times up by 1,000 to get to a kilobyte. Got 16,000 right there. So it's going to be 16,000 bits. Okay? Number 11. The ASCII value for the character X is decimal number 120. So we've got to complete the table, basically. So ASCII value for W, 119. Unicode value, 119, or it'll be 119 also. For Y, it's going to be 121, and you could just have 121. Here you could have 122, and you could just have 122 for its Unicode. And for here, you could just have 120. Yep, keep it simple. That is how that works. Okay? On with the next one. So number 12, we've got figure 1, we've got 10 by 8-bit map image that uses 3 colors. So we need to calculate the minimum file size that be required to store the bitmap image in figure 1. So we got to give that answer in bytes. So it's 10 by 8. So it's going to be 8 times 10. That's going to give us 80. Okay. And the color depth is going to be a 2. So we need to multiply. So we have got to multiply that by 2. 80 multiplied by 2, 160. And then it's going to be 160 divided by 8. And that is going to give us 20. But let me check. I know AQA says not to use a calculator because they can be little farts. Okay, so let's do that. Yep, 160 divided by 8, that's 20. So that is the correct answer altogether. So you can see I've done 8 times 10 is 80. Figured out that the color depth is 2. So 80 times 2 is 160. And that divided by 8 is 20. Done. On with the next bit. How many more to go? Okay. Analog sound must be converted to digital form for storage and processing in a computer. So we need to define the term sample resolution. Sample resolution is the number of bits per sample. That's all you need to say. For number 2, 13 part 2, state one disadvantage of a high sample resolution. You could say larger file size, some files will take longer to download, or you can have users more memory. I would just say larger file size. Larger file size takes up more storage space. Okay, part 3. A 50-second sound has been recorded at 40,000 Hertz. 2 bytes have been used to store each sample of sound. So we need to calculate the file size in megabytes. So we got 40,000, okay, and 50. So we need to multiply 50 times 40,000 times 2. Okay, so 50 times 40,000 divide by 2. Not divide, times by 2. So it's 50 times 40,000 times 2. So that is going to give us 4 million. So we got 4 million. Okay. So what we need to do now is we need to do 4 million divided by 1,000. So that is going to give us 4,000. Or what we could do is we could divide that by 1,000,000 and have done with it, which will give us 4. So if you get a 4, that's 2 full marks right there. So for now, 50 times 40,000 times 2, 4 million. Divide that by 1,000,000, 4 megabytes, bosh. Done. Okay, let's get to number 14. Computer networks have been installed using wired or wireless technology. So we need to state one wireless method used to connect devices on a personal area network. So Bluetooth, that'd be the one that I would use. Number 2, describe 2 differences between a LAN and a WAN. LANs cover a small geographical area, WANs cover a wide geographical area. That's 1. So that would get you 2 marks. Done. Right. 14 part 3. Give 3 advantages of using a wireless network instead of a wired network. No trip hazards, guest access, and mobility of users. They would be the 3 that I would use. 14.4. Shade one lozenge to indicate the application layer protocol used for sending emails from a client device to a mail server. It's not going to be file transfer protocol. It's not going to be hypertext transfer protocol, and it's not going to be UDP. It's going to be simple mail transfer protocol. Which takes us to part 5. Explain the purpose of HTTPS. So the purpose of that is to send and receive web pages using an encrypted connection. You could say more secure web transactions, authentication of websites being visited, but I would say sending and receiving web pages using an encrypted connection. That'd be 2 marks there. 15. State 2 issues with using usernames and passwords in an authentication system. So the 2 issues are weak passwords are easily cracked, and usernames may have appeared in a data leak or susceptible to shouldering. So I would say weak password words can be easily cracked, and username and passwords may have appeared in data leaks. 15 part 2. Describe one security measure that could be used in addition to a password to make sure the user is who they're claiming to be. So you could say biometrics will reference data as compared to the individual's biometric data. That's one security measure we could describe there. Or we could say an authenticator app on a mobile phone which generates a code which the user uses to complete the login. Or we could have 2-factor authentication, which asks for a second form of identification like someone you know. So if I was doing this, I would say biometrics references data that's compared to the individual's biometric data. 15 part 3, state 2 reasons why automatic software updates provide better security than the manual. Because a user may forget to do updates manually, and automatic updates mean a computer is protected more quickly. That's 2 marks right there. Okay, 16. It's basically saying, what's pen testing? It's the process of attempting to gain access to a resource without the knowledge of, or you could say it's the process of attempting to gain access to resources to find vulnerabilities. And then part 2, describe the aim of a white box penetration test. It's to simulate an attack from an insider who has the knowledge of the target system. 17. Need to state 2 reasons why data are compressed. 1 is to reduce file size, and 2 uses less memory. That is what I would say there. And 17 part 2, we got a string. One method of compressing data is run length encoding. So when we're using it, the data in figure 2 is here. So we need to explain why run length encoding is not a suitable method for compressing the data. Reason being is because the data doesn't have a high frequency of consecutive repeating characters, and the data will take up more storage space. Okay, that is why we've done that. Run length encoding is not a suitable method, because the data doesn't have a high frequency of consecutive repeating characters, and the data will take up more storage space. 17.3. Another method is Huffman encoding. So that's where the code for the characters can be created based on a position in a tree. So figure 3 is the Huffman code for each different character in a string. Figure 2. So then we need to complete the Huffman tree to show the position of the characters I, S, and P. So go out M. So in here, we're going to have I. Down here, we're going to have S. And then here, we're going to have P. That would get you 1 mark. Okay, 18. Relational database has been developed for a youth club to store information about the members and the awards they're given. So we got the member table and we got the award table. So we need to define the term relational database. So relational database, it's a database with multiple tables that are linked together. That's all you need to say. No more, no less. So it's a database with multiple tables that are linked together. On to the next one. State 1 benefit of using a relational database. Reduces data redundancy and reduces data inconsistency. Any one of those would get you 1 mark. Next one. State the name of the field from a member table that is most suitable to use as a primary key. It would actually be the member ID, because that is the primary key. Okay, state the name of the field from the award table, that's a foreign key. So a foreign key, it's a primary key that links back to the table where it's the primary key. So member ID is the foreign key that links back to the member table. So it's going to be member ID. So this sort of question, you just need to read the information that they give you. Right, next one. So we've got figure 4 included again. So this is where we will have to do SQL. So the youth club needs to produce a report listing members who've been given the leader award. So the report has to have both names of each member and the date the award was presented. So we're going to write a query that could be used to find the information. The results have to be in the order of date of the awards that were presented, starting with the earliest. So if I had to do one example, you could do something like that. Select first name, last name, date presented. It's going to come from the member and award tables. And then we're going to have, in the where clause, we're going to have a join. Member.memberid equals award.memberid. And we're going to use the AND operator, award name to equal to leader. And we're going to order by date presented in ascending order. So that is what will get you your full 6 marks. So 1 mark for the select clause, 1 correct table in the from clause, another mark for saying another table in the from clause, that's correct, and another mark for the where clause, a correct condition in the where clause, 1 mark for the correct conditions and the correct use of and in the where clause, and 1 mark for a correct order by clause. So all of these will get you 6 marks, no problem there. Okay? And then we're on the last and final one. A new member joins the youth club. SQL, column SQL is run to add the details to the database. Some of it's been replaced by labels. So we need to state the SQL that have been written in places of labels A and B. So in A, it's going to be member, and then in B, it's going to be values. Because that is basically, we're inserting into the member table these values. Okay? And that, ladies and gentlemen, takes us to the end of those questions there. So, that wraps up our deep dive into paper 2 of the AQA GCSE Computer Science specification, particularly for the paper 2 of 2022. I hope you found this video helpful and gave valuable insights to help you succeed in your exam. If you found these tips useful, don't forget to hit that like button and that subscribe for more content like this. Remember, practice makes perfect, so revise you must, and on your way to acing that exam, you will be. Thanks for watching, and we'll see you in the next video. Goodbye for now, and good luck. So please be sure to hit that like, and please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which made me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. all you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, whatever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted, and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a REPL link below on my programming videos. So you just click on REPL, and this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click log in, and once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page. So this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specializing in ICT and computer science. And I look forward for you coming to me for lessons. Goodbye for now.